So, a little bit more about Resource E as a background. Who needs to go about selecting anchoring phenomena? And so this is for facilitators of professional learning. So those could be teacher educators, either pre-service or in-service, who are really interested in an experiential approach to helping educators understand phenomena. But it's also, as I mentioned, I think it's a good tool for people who are leading curriculum design efforts locally. Many people are interested in developing units with teachers or perhaps entire curricula. And so this is a tool that can really help you to find some key good anchors for those curricula materials. In terms of the participants, it could be educators who are really at the beginning of their journey, but it could be, again, people who are really focusing on this identification of phenomena that are aligned to standards. If we think about this as choosing phenomena that are both aligned to standards and also concerned with students' interests and their community's priorities, that is a lot to actually have to hold together. And this process helps you hold all of those things together by gathering information, for example, on students' interests or backgrounds, things that might be of concern to them, as well as doing the deep dive into the standards. And having worked with this resource and worked with teams to develop anchoring phenomena, I can speak to the complexity of this work. This resource is really intended to help with that complexity. So I've put the link to the slides. These are active links. These would be the things that you would need when you're leading this particular activity. There's a link to the slides on the STEM Teaching Tools website. Lydia has put that link into our chat where you can find all of these. There's a facilitator overview that can be helpful in giving you just a sense of what is this thing. You will need phenomenon game cards, and there's a little bit of prep work. There's a way that you cut these things out and you create little bundles of them for different groups of people. We're going to use Jamboard today because we're on Zoom, and Jamboard is a really good tool for when you're doing this virtually. There's a template for the unpacking or analysis of the standards, and there's also sets of examples of unpacked standards. It's rare that teachers have sufficient time, or we give sufficient time to do a deep unpacking of the standards. So it's good to have these models to stand by to do what I call a cooking show version. It's like, let's get this started, and then let's come back 30 minutes later, and poof, you've got a nice souffle or something like that. So here's a finished product of what it looks like when you see some standards that are unpacked. All right, I'm going to ask everybody now to switch. This is my image for learner hat. So I want you to think about this, and we'll invite everybody who's here to be thinking about this moment of being in learner hat, where we have an opportunity to participate as teachers might. So think about a teacher that might come to one of your professional learning workshops, or come to, if you're facilitating with peers, maybe to your teacher work group, and see if you can get inside a little bit how they might participate. And I invite you to bring that here too. And that might be a teacher who's newer to phenomena, someone who's skeptical. Just have someone in mind as you bring it on and become a learner. And I'm going to shift into facilitator hat, and we will have time to step out of this mode, but I really invite you to experience this as an educator might for a little bit. So with that, you're going to need access to this Jamboard for something phenomena game. I'm going to flip over to show that. What you will see here, I'm going to just explain what we're going to do here on this, is that there are several groups. There's about, I think I've got 6 groups set up. Yes. 6 groups, and each of you has some stickies that you can move around like this. And I want you to then, each group, I'm going to invite, may not do 6 full groups, but actually that's probably a good number for this number of people, is that each group is going to then line up. Do you think that this question is a question that relates to a phenomenon, a design challenge, or a disciplinary core idea? I'm not going to define these up front. We're going to see together if we can kind of figure out what the difference is between a phenomenon, design challenge, and disciplinary core idea. What are these questions? These are like essential questions or driving questions that could drive a whole unit of instruction. So I'm asking you to think about, is this driven around a phenomenon? Is it a driving question for a design challenge? Or is it a driving question for a disciplinary core idea? So before I send you into breakout rooms, what questions do people have? All right. Has everybody got access to the Jamboard? Have you clicked over? Do you need me to, let me put that in the, I will put that in the, whoops, chat for everybody. Sorry. Thanks, Bart, for that. There it is. Now does everyone have access? Anybody having difficulty joining the Jamboard? Okay. I am gonna check in with you in about 10 minutes, but I'm gonna monitor via here, and so I might bring us back sooner. But I want you to be prepared to share out when you come back some of your placements that you struggled with and your reasoning for that. So that's going to be our task when you come back. And I'm going to open the book, open the rooms. Welcome back, everyone. We're still in learner hat, by the way. And I want to call on one group at a time. And I want you to tell us a little bit about one of the ones. Let's start. We'll probably only do one round of this. This is a place we're going to cooking show this a bit. Tell us something that you struggled with and where you ended up placing it and what your reasoning was. So we'll start with the small group 1, which was Brent, Cindy, Lydia, Mary. Give us one that you'd like us to maybe talk about. Even if you had just the lightest bit of trouble with it, it's fine. Maybe this was easy for you. I don't know.
I guess I can talk about one of them. We kind of put our ones that we had more discussion about down at the bottom of our Jamboard. And so one of those we talked about was, how do our digital devices produce and detect sounds we can hear? Because that, how an electronic device works or whatever relates to disciplinary core ideas, but it also could be made more into a phenomena, here's this scenario with a digital device or whatever, and it's able to do this.
So what would, in that case, tell me about what makes that second scenario more of a phenomenon than just the way the question's asked now?
Because it's something that's occurring out there in the environment, either the natural or designed world, and you can learn about it and investigate it, and in the process uncover some science concepts.
Okay. Wow, that sounds powerful. Let's hear from another group. Group 2. God, give us one that you struggled with and tell us where you placed it and why, ultimately. That is Dustin, Michael, and Monica.
Well, I'll go ahead. We were struggling with that exact same one with the iPod and the sound, and we still have 2 of our cards down at the bottom because we were in the middle of that discussion before we got pulled back, and pretty much what number 1 said is kind of our thought process. I think one that came up fairly easy for us was some of them were just obvious it was a phenomenon. Why were the shells of sea butterflies in the Antarctic water dissolving? To us, it's like, oh, that's definitely a phenomenon. Some are just really easy to pick out, but that iPod one and sounds and stuff, that one got us talking.
What makes the three that you had in the phenomenon category obvious to you?
Well, it was just
To
something
me,
that,
it was like,
go
it
ahead.
was very specific. Like it was a really tangible thing that you could see, touch, or kind of vision in your head. That was what it was for me. Where
Okay.
the two that, like the digital device one, there's nothing tangible to like grab
Okay.
on it.
Something specific,
reference.
something tangible. Monica, you were about to say, give an answer to.
No, I'm good.
Okay. Well, let's move on to group 3, and why don't you share one that you struggled with a little bit or had some deliberation about? That is Aaron, Amy, and Joanna.
I can share that we actually found the asthma attack or flare-up one a little bit hard to classify as a phenomenon, because like in anatomy and physiology class, that would really just be you'd have like a coherent explanation for what was going on, although it's not a DCI. So
Yeah.
that one felt a little bit funny to place as a phenomenon.
Okay. And do you have an idea about what would be a question you could ask that would make that a phenomenon, that one?
I was thinking a question more like asthma attacks. Asthma is on the rise. Like, what are the factors that are driving this? So something that would be more about it as like a cultural or justice phenomenon.
Okay. And so something related to culture and justice, anything else that makes it different than just what happens to make it harder to breathe?
Joanna, did you want to speak about it? I mean, I also think it could be interesting if you were like, maybe framing it as here's like debates in science about what are actually the mechanisms that are driving the asthma attack.
Yeah. Okay. So sometimes we want to frame it as something that's like problematized, something that's up for grabs. Sorry.
And I think that is what got us, is when we feel like there's a very specific mechanism that is the explanation for something, it doesn't feel as rich. And of course, I'm a high school teacher, so I'm really focused in on that level of thinking. But yeah, we kind of talked into the what versus how and these question words and cueing in on what they meant to us. And then we started talking about, well, maybe some of these are just better phenomena than others. So we started kind of ranking them too about what really counted as quality.
I was going to ask, there's phenomena, but then there's good phenomena. So what are the criteria for good phenomena that you think should be on the table?
I would argue like it's a genuine question where there's no clear solution. And I think you can get a lot of leverage with kids if there really is some ambiguity and they get to feel like real problem solvers. And also like the more you can make it grounded in like larger topics that they're going to potentially care about, that helps a lot too.
So connected to larger topics I care about. Let's move on to group 4. Want to share one that you were maybe struggling with?
So we had a lot of discussion about the one that said, how should we slow the increase in global temperature by changing how we get around on a daily basis? We felt like that was a really big topic, global warming, climate change. There was an aspect of it that felt like a design challenge because you're like thinking about transportation and like designing transportation systems, but there's also kind of this like phenomena idea about like how do people's actions contribute to the global climate, that felt like it could be more of a phenomena, something that could drive a unit. So we cheated and we put it between the two categories.
Yeah, right.
Because we felt like it kind of straddled both of them.
Well, you could imagine a unit organized around that question that investigates the phenomenon of anthropogenic climate change, and also then moving into the design space of thinking about what to do about it. Certainly, yeah.
I just wanted to offer as well, like that, part of that, why we struggle on that too, is like there's an opportunity for people's values to contribute to how they approach this question, and making that kind of value-based opportunity in some of these questions, I think is one of the things that help us explore other elements of the phenomenon.
Where do values show up in phenomena, design challenges, and DCIs?
My opinion would be they'd show up a lot more between, in the design phenomenon spectrum, I think.
Why there?
I'd say because the complexity of the phenomena offers space for people to interpret it in a whole bunch of different ways. So it's not just scientific facts that we're looking at. We're looking at what do we bring to this conversation. And I think in the design challenge, it's part of, how do you approach that design challenge? Or like, what are you going to uplift above other things? So we're going to solve the climate crisis by creating all these carbon sequestration stuff and building that economy, or are we going to slow the economy down and reduce the amount of energy we use, and it's like they both kind of bring value perspectives to this thing.
Yeah, the framework certainly gives an explicit role for values in the design challenge bucket, but I would argue they're in phenomena too. Because especially to the extent humans are part of nearly any phenomenon that we would look at on Earth anyway, right? That we are shaping those phenomena, and so our values and actions. And they probably also show up in the DCI in a very broad sense of like, well, how do we even frame these DCIs and which ones are here and which ones aren't? So, but they have an explicit role in the framework and the design challenge. That's great. I appreciate bringing in values. How about group 5?
So on group 5, we actually did the exact same thing group 4 did. We left the global temperature one in the middle, and we kind of discussed it a little bit. And then we ended up settling on design challenge just because you would have, I don't know. Actually, I don't know why, unless one of my group members wants to say anything about that. But we ended up going more design challenge on that.
That's great. Let's move on to group 6 in the interest of time, so I can hear from every group.
I accidentally closed out my Jamboard, so I don't have it. But we talked about, that idea of which of these are DCIs specific and which do blend more into the other ones. And so I think one of them that came up was the wave one. And then we kind of got off topic about other phenomenon that we use.
Yes, yeah. Let's pop up a level, and I'm wondering if someone would be willing to then, based on kind of where we've placed things, how would you give a little definition of phenomena? Like, what do we seem to be implying, or what makes something a phenomenon? You can come off mute. You can also add ideas about characteristics in chat. So focus not on what makes a good phenomenon, but just like any phenomenon. What makes something a phenomenon?
I would say it has to be observable.
By your naked eye?
Well, I would say senses, something that you can sense.
I'd say relatable too.
Maybe an experience.
Okay, an experience, relatable, not straightforward to answer, Cassandra says. What else?
I don't think it necessarily has to be relatable.
Oh, okay.
Wouldn't you want them to wonder about it? So maybe not being relatable would increase the wonder and the curiosity.
Okay.
Yeah, like Erica was saying, I was thinking a phenomena is something that like makes you ask questions, like catches you by surprise, catches your attention, makes you ask questions and want to figure out more, something unexpected.
Can something be a phenomenon and be relatively not necessarily phenomenal, as our friend TJ would say?
Yes, I think so. Somebody just said it's unexpected and surprising, but there are everyday things that are phenomena too, right?
Right. Yeah, so there might be some everyday things in there. Okay. Gonna cooking show this, we would probably go through, and normally I'd have people bottom up the same thing for design challenges and DCI, but we're on a roll, and this is a great group that I think you guys really are getting. You guys got the gist of this. I'm gonna stay in here and learner hat for a little bit longer, and I'm gonna grab your screen again to walk through a couple of things to present. So let's look at a definition that comes from Achieve that we can work with. So there are phenomena that are observable events. We came up with that, didn't we? Right? That occur in the universe and that we can use our science knowledge to explain and predict. And really this relates to, well, why do we want to do this? Because we're trying to build knowledge to develop these general ideas based on evidence that can explain and predict phenomena. So phenomena are really key in this new, in our new standards. They are the key thing to think about those in design challenges when we want to think about, well, how are we going to meet this vision of in the framework for K-12 science education? There are different, as we've just talked about, there's different kinds of phenomena. There's some that are anchoring that we use to start a unit and actually run through a unit. There are investigative phenomena that might go over a couple of days or one day. They're everyday phenomena. In assessment, we talk about a scenario that is a written way to present a phenomenon to students in a way to assess their knowledge. It can be a case of something, and it doesn't necessarily have to be phenomenal, but something that people can observe. So we got that observation piece here too. And that can be something puzzling that's in the everyday, like how come rainwater isn't salty, right? Especially if you're living on a coast and you're really near the ocean. It's not just what we can observe directly. Here's a nice image from the Webb telescope. So when we think about phenomena, we don't want to just have phenomena that are things that we can see with the naked eye. We also don't want to forget the underwater and the microscopic. Those are also really important too when we think about phenomena. Design challenges are things that involve us using our engineering skills and practices, but also I love bringing in values, like because it really depends on values, where we get to use our science explanations to design solutions. So that, climate related unit of question probably is a great example of a design challenge where we're going to have to learn some science about fuels and how in anthropogenic climate change in order to actually come up with our design solution. All right, so we can come off for a little bit, and I just wanted to spend a couple of minutes, inviting people to share any reflections in chat or out loud if you wish. What do you feel as you experience this particular game, and what do you imagine educators would feel as they did so? And if you've led this, you can say how educators have experienced this.
I mean, I guess I can say that in Ohio, we teamed up with our NSTA affiliate, SECO, and led a series last fall on science's phenomenal. And we used some of the things from this resource in that. And Ohio is not an NGSS state. We did build our standards off the framework, but it looks really different.
Yeah.
And so our educators are not very familiar with phenomena, and these kind of experiences, I think, really helped them understand a little bit about what it was all about.
Yeah, Dustin adds a little bit about the fear of being wrong, and I think connected to this, when you have teachers who are new, they're going to struggle with this, placing these in ways that I didn't see the group struggle. Like I saw you all move really quickly in putting some of these together. I would give 20 minutes for this activity, like in order to really let people struggle and have the conversations they need. That's on the front end. And then I would really let that conversation go long that we just had in like 5 or 6 minutes. So.
Yeah, our teachers had no idea, when they were starting out. So,
yeah. What else? Anybody else want to share things that they imagine teachers might experience?
Well, one of the things that I experienced is I was caught off guard for a minute because all of the Post-its had questions on them.
Yeah.
And we had actually done a training here where we talked about how phenomena aren't the same thing as investigatory questions.
They're not.
So
Yeah.
that was like a little dissonance for me for a minute to kind of think about how would I take all these questions and think about them in a way to place them in the categories.
That's great. And you're going to see an adaptation that does it differently. So if you look at the resource, it actually has a description of the phenomenon that is connected to the questions here. So teachers can review that and see, yeah, the phenomenon is actually the event, not the question. So other observations here, Amy in chat says we could really help with teacher confusion that muddles the quality of student inquiry, love to dive into sorting phenomena into quality, how to use them, etc. Yeah, these aren't all great phenomena. That's a little bit on purpose. Like we try to have a variety here because this can actually spark, and also have some that are ambiguous, because those are the things that spark good discussions.
We, in Arkansas, when we were doing it, and even with doing a TOT with our specialists and with teachers, and I heard it today in kind of a small group, they want the correct answers. They want they eventually want a right answer. And so after we played the game and we came up with some criteria for them and we were moving on to the unpacking, we said, here's what we thought, or here's where they could fit in, and kind of give closure to them after they've struggled, after they saw the categories. But we did that. We helped guide them or show them kind of the right answers. They struggled.
Do you want to go ahead and I'll move us along, and we can talk about your adaptations?
Right. So Saundra jumped in and kind of stole my thunder there. I was going to mention that. Emily, the first thing that we did when we saw these questions was we had that same thought, was that we had been told and we had been telling our teachers forever since 2015 that phenomena are statements. They are observable things in the natural world that you want your kids to be able to explain through science. And so you can ask questions that lead to better understanding of that phenomena, but the phenomena itself should be a statement. So we did that. We took the questions and we tried to stick as close as we could to what was there and make it into a statement. So we moved from how can a desert that gets almost no rain support life to a desert can support life despite getting almost no rain. Because we didn't want there to be that confusion with our teachers. They're already confused on a lot of levels. So that was a way that we could get rid of some of that confusion. And then another thing that we wanted to do was we wanted teachers to be able to kind of take some of the ideas that we had back to their classroom immediately. So they could take this phenomena idea and use it in their classroom. To do that, we needed it to be really Arkansas specific. So for instance, there was one that's a question that says, how did the beautiful arches found in the four corners form? Well, a lot of our kids, especially in Northeast Arkansas, have not left their county. Life doesn't exist outside of the county that they were born in. And so we wanted to make these Arkansas specific. So this question is really getting into erosion, weathering. And so we were thinking about things that we could do local for that. And the White River or the Buffalo River, we have some really gorgeous rivers that run through our state, and they all have these amazing bluffs that line aside of them. And so on the same vein of weathering and erosion, we have these bluff formations. The way that we kind of took this card sort thing and made it our own was that there are, I think there are 36 cards. So there's like 4 categories, and there are 3 examples in each of those grade bands. And so there's 36, and we looked at who our participants were. If we had mostly a mixed bag of teachers that day, say we had some from elementary, some from middle, and some from high school, then we were going to focus on kind of the 3-8, so the 3-5 and the 6-8 grade band cards, so that they weren't sorting all 36, but they still had 18. So they had enough that they could really get a good idea of what was going on there. And they did, they struggled. They really, especially with some of the more ambiguous ones that we didn't change, they really struggled with whether or not this was an observable event or the science behind the observable event, or the problem that students should try to solve using the science. Once they got through that, though, as Saundra mentioned, we did provide them kind of that soft landing. Here's what we thought, here's how we categorized them. And then we asked them for feedback as well. So we did this with our pre-service teachers, and then we did this with a group of teachers before we went to our training with our specialists that provide the professional development. And then, as Saundra mentioned, that was our biggest attended event during the summer.
Great. Thanks so much for sharing that. I think it really helps to have these adaptation examples and seeing how you've shifted things. We're going to go to another part of the session, which comes kind of after this, which is that we begin to unpack or analyze the standards. You should have view-only access to this particular template. So I'll ask you to just spin off and say, use the under File, make a copy for yourself. We'll do some work in small groups with this too. But I'm going to also ask you to get back into learner hat now once you have that open. Anyone having trouble accessing that at all? Okay. So, why do we actually spend time analyzing the standards, right? Should be pretty simple. But it turns out these three-dimensional standards are really complex, and a whole lot is packed into each one. A single sentence has a whole lot underneath it, a whole bunch of stuff from a framework from K-12 science education that highlights all of the three dimensions that, the key elements of those dimensions that we're supposed to be addressing in these standards. And so spending time actually with making sense of these can create a clearer sense of what the learning goals are. For many teachers, it's learning that this thing that I've always taught isn't actually in the standards anymore, or that the way that I've taught this thing now, it's really couched in a really specific way, focused around a specific kind of practice. In analyzing the standards, the other reason we do this is we often get some good initial ideas about the phenomena that we might want to explore later. And before we move out of the space of analyzing standards, kind of let off that release valve of feeling like, oh yeah, now I'm starting to get ideas. You're going to get ideas about phenomena as soon as you start unpacking the standards. It also really helps if you're working with teachers in a school to help know what your lane is. So am I in the elementary lane? What is expected elementary? What's expected middle? What's expected at high? It's so important when choosing phenomena to really think about, look on either side if you're in middle school, or look a grade level up or a grade level down if you're in high school or elementary, and to really see like, what is it that's specific to my level that I'm supposed to do? That really helps us to both ensure that we're teaching what we're like is expected at this round, and also the vertical alignment. What is actually good about the framework is that there's 16 or so big ideas that we're dealing with. Kids are coming back to it year after year. So this alignment to grade level is important because we're going to cycle through these ideas. Kids are not getting only one touch with a big idea in science. They're getting a lot of touch points with it. So I want to give you a little bit of guidance before we go into small groups, and I'm going to rearrange, I think, the breakout so you get a little bit of a chance to work with some different people. We'll have four groups this time. So I want you to use the framework text, which is right underneath the standards in that document. So if you look underneath those connections boxes, you will see some red, some blue, and some green. The yellow, the orange, the blue, and the green. And that orange, especially, we're going to look at, that comes directly from the framework. That's the thing that we're really trying to get at when we are addressing that standard. Clarification statement is also tremendously helpful in helping us think about, what does this really mean? And I can stare at these things for a long time and still miss things, so hang out with this. Here's a trick. When you unpack, what I want you to do is to formulate these things as claims about what kids should know and be able to do, and formulate them in complete sentences. If we write one word, we don't leave enough of a breadcrumb for us later to understand what we mean by that. So don't write electricity, write a claim about what it is that kids are supposed to know. consider the different facets or aspects of the ideas. There's not just one thing here that is typical. There's lots of different aspects to a single idea. And also consider the knowledge that students would need that's foundational for the ideas. And in the case of the template I've given you, what's some of their everyday experiences or prior interests that might be able to be leveraged in teaching these ideas? And when you're tempted to write a definition to unpack, instead of writing X is this, try to say what X explains. And that's actually going to help you also start to do this and brainstorm some phenomena. Here's some examples of facets that sit underneath, just as a model for you to follow. So this is a 4th grade performance expectation. Construct an argument that plants and animals have internal and external structures. Function is supported survival, growth, behavior, and production. Ooh, that's a lot. So there's a facet of this that's like all living things have structures and serve important functions to them. Some of the structures are things we can see that are external, and some of them are going to be external. So I've broken this down a bit. And the point of breaking it down is not so I can teach these fact by fact by fact, but to help me really think about what are actually the pieces of a phenomenon. That a phenomenon is going to have the affordances of being able to help us look. I need a phenomenon in this case that's looking at structure and function. The phenomenon is going to have me engage with something that's external and external. So it's helping me really understand what is required of a phenomenon in order to be a good phenomenon for this performance expectation. All right, what questions do you have about getting started with just breaking down and discussing and unpacking standards? Okay, I am gonna check in about 10 minutes on this, and it will feel too soon, I guarantee you, but that's the time. That'll leave us some time to do the rest of what I have planned today. So I'm gonna open the rooms, make sure, and maybe somebody in each room can share their unpacking templates so that you are looking at a shared screen and can see the work of the group. I realize that was wholly unsatisfying, and I apologize, but this is what a run through of a resource looks like rather than doing it. One more, just stay in learner hat for one more thing. My Arkansas colleague said I should really ask if people got some ideas about phenomena from just this activity, if you wanted to share them either out loud or in chat for these. Any ideas? Maybe you already had one that you love for this particular pair of standards, but anybody have ideas they want to share that you got through doing some unpacking? I heard group 1 talk about something they said was not a good one, like with doing the rock cycle, say standard rock cycle. But
I think after you left, I said sometimes we use a lava lamp to help with this standard, to think about like, how does a heat source in one place allow things to like move around in predictable patterns?
But how do you get that back to the analog of the actual world, right? So when we're doing modeling, it's so important to help kids understand what the model's good for and what it's not.
Yeah. Well, and that's a great opportunity to have that discussion. And then why also do you need multiple models for the same phenomena? Because some models show one aspect and some models show a different aspect, or help you focus and explain a different part.
Yeah. Oh, you find that Amy finds this one puzzling to figure out something on this side. Well, one of the things that I think of that's kind of related is that related to justice is that we try to move things around, try to move earth material around a lot to create space for cities and to dam up lakes. And there are a lot of justice issues around what happens when we dam up lakes, for example, in order to get electricity for the communities that live there, for indigenous communities. You can think of the city of New Orleans as an interesting experiment in what happens when you try to control erosion of something that doesn't want to be controlled. So actually I think there are a lot of really interesting phenomena with this one that you can think about. All right, so let's pop up into Facilitator hat. I won't grab your screen from you just in the interest of seeing faces for a few minutes. Any thoughts about this activity from the standpoint of how you think your teachers would experience it? Like pop up and reflect on, as a facilitator of this, what comes to mind about how teachers experience unpacking?
I think the reason why Christina and I were talking about the not the rock cycle with this is because one of the things that happens when I've sat down with teachers to try and unpack the standards is helping them see past their preconceived ideas about what they think the content is supposed to be, or what they've always taught, or what they love to teach, and help them actually look at what is it saying and why is that important.
Yeah, that's a great point. And it's hard, I think it's hard to do that, right? So one strategy might be to like, okay, look at this in 30 seconds and write down what you think it means. Now let's slow down and read it again. Let people get out their ideas about what they think it means, but then say, hey, let's go a little deeper now. So you could think about that as a two-parter, you know. What other thoughts about the kind of experiences that you think your students or your learners or teachers would bring to this?
So one of the things that I think comes up a lot is when you're looking at the performance expectations, teachers are still thinking in objective mode, objectives, and how that this should be an objective that covers a specific topic and go to the next objective instead of looking at it as a performance expectation. So that's been the challenge for teachers here, because it's a big performance expectation that covers a lot, and they wanted to cover that one objective and be one and done.
Yeah, and this is actually a danger of unpacking, is that people turn these into little mini behavioral objectives. So you got to keep coming back to the reminder, why are we doing this? It's helping us to really understand what is and isn't there, helping us to think about the kind of phenomena that are really going to provide us with opportunities for learning these big ideas. So good, really good point, Michael. It's a risk of even doing this, actually. Let's hear from our Arkansas colleagues. I'll put the slides up for you. You all had made some adaptations to this. You want to share a little bit?
Yes, thanks, Bill. When we ran through the Resource E with the pre-service and then with the teachers, we wanted to look at how we could take the process and really boil it down into very specific steps for our teachers to follow. Our teachers really, they're, as you guys are, extremely busy, have lots of things to do. So they really wanted something where they could just see, you know, step by step, what do we do in order to unpack these PEs? And so we took the basics, the fundamental strategies of Resource E, and incorporated into this document that we're working on. We're still working on it. The main strategies of relying on the framework rather than our own personal knowledge. We stress to teachers, please rely on the framework and really dig into what are all the different elements and facets of the DCI to make sure that it is rich enough to support a good phenomenon. I'm going to put in the chat our draft so you guys can kind of take a look at it while I describe it real quick. So I missed linking it into the slide, so I'm just going to put it in the chat here. and you can take a look at it. So in our unpacking document, you see here that we have at the top, we have a why. As Saundra said in the chat, it's really crucial that that teachers understand why they're doing this, that a lot of our teachers misunderstood the PE, the performance expectations in the beginning back in 2015, when we started working with the standards in Arkansas. A lot of teachers looked at the top part where the PE is stated as the teaching part of the standard and didn't even look at the foundation boxes at the bottom. So we have worked very, very diligently to get teachers to realize that the teaching portion of the standard is the 3 foundation boxes at the bottom of the standards page. So we have that why listed. And then you'll see here that we have all of the unpacking in very specific steps for the teachers. The step-by-step instructions take them to the standards page and to copy down what PEs they plan to bundle for their unit or for their lesson. They copy those into the document, which you see here on step 1. Then they will include the clarification statement and the assessment boundary so that they are familiar with that. Then they go to the framework and the DCI progressions matrix, which if you look down here at step 2, in the process of actually unpacking, they are copying down the elements from the foundation box onto their document, for example here, LS1.A, and then copying down the bulleted item in the foundation box underneath that subheading. And then they go to the progressions and read and describe how does that differ from LS1.A in the lower grade band, and how does it differ from LS1.A in the next higher grade band. And this helps to keep the teacher, keep the lesson at grade level, and also to inform their instruction of, you know, what do they expect students to come in with, and have that awareness to know what to do if students don't come to them with that prior knowledge to do an intervention. Then they break down those items in the bullets by looking at the framework, which you see here on step 2, part 3. Once they break down the details from the framework, then they think about what does the student need to learn in order to make sense of their phenomenon. In other words, they take that big idea and they break it down into smaller and smaller details in bulleted. And here's an example of how that bulleted step could look. They would have the foundation box statement in bold. Then they would put down the description of the grade band above from the DCI progression matrix. Then they would describe how the PE, how the DCI in their grade level differs from the grade band below. Then they do that for the grade band above. Then they start listing the details from the framework, the details of the DCI. Then they do the same thing with the SEPs and the CCCs. And here we have added in another step of adding STEM teaching tools, prompts to put in some possible performance task. So for unpacking the SEP, the steps are still pull it from the foundation, the blue foundation box in the K-12 science standards, and then use the progressions, the SEP progression, to see how that SEP differs from the grade band below, grade band above, and then make bulleted statements. And they could use the STEM teaching tool number 30 to find a performance task and put those in. And then we have an example here. Then finally do this with the cross-cutting concept, same process of obtaining the appropriate CCC from the foundation box, from the green box on the standards. And by the way, Arkansas adapted NGSS, so our standards look very similar to NGSS. Our main difference is that we, rather than having a middle school and a 9-12 grade band, we put the standards in specific grades in middle school and courses in high school. So coming back to the CCC, we go through the same process of obtaining the CCC, comparing it to the grade band above and below, putting in bulleted statements of how those CCCs might interact with each other, and then pull some possible performance prompts from the STEM teaching tool number 41 on cross-cutting concepts. So by doing this, it gives teachers a very specific how-to go through this, because they're not comfortable with unpacking standards at all. So this will give them some added support to scaffold their learning and their mastery of unpacking. We plan to pilot this in February with the teachers who, some of the teachers who went through the training back in the spring and summer. And then we will make any adjustments based on their feedback. Then we will roll it out to our specialist in a TOT in April. And then we plan to use this document consistently throughout all of our PDs. We have a suite of PDs that include an introduction to the standards, how to read the standards, how to develop assessments, how to, of course, the anchoring phenomenon, as Saundra and Aaron described earlier, and also how to develop three-dimensional coherent units. So in those PDs, we plan to use this document to support teachers in unpacking their PEs. Then we hope to, we are planning to create this as a standalone training next year, possibly a 3-hour PD.
It's great. Thank you so much. We just have a few minutes left. I want to have at least a couple minutes for questions, but I promised you I would give you a little overview of the whole thing, because I said, hey, this is a big, long unit. So I'm gonna go through these couple of slides here. Hopefully you are seeing that. This will give you a sense of what these sessions look like. This is intended as a workshop that would go in 2 parts. So we actually have people experience a phenomenon in student hat or learner hat. So they would be introduced to something. And this is, again, a thing that you can adapt. There's so many good materials out that have been developed since we created this resource, that you could pick like an Open SciEd unit or anything that's like a powerful unit and get people into experiencing what it is to do that. Then play the phenomenon game. Then we do that definitional work, and you can see a lot more time is allocated in the session for the game and the definitional work that we did today. Then the analyzing performance expectations. Then we give some people some homework to do of taking photos in their everyday world and environment, or bringing photos from the web if they want, that are related to the performance expectations. So this is a kind of photo elicitation task. And then session 2, they share those out. We also then do some brainstorming and grouping of phenomena together, of things that we might think about related to those. And we then go take people through the idea of constructing an explanation for the candidate phenomena. We have discovered this is a really important step in selecting phenomena, is to write an explanation to convince yourself that kids actually need the science ideas that are in the standards to explain the phenomena. You would be surprised how many cool phenomena do not require science ideas to explain in a way that would be satisfying to a kid. And then you're up a creek if it doesn't really have that juiciness to it. Then we talk about our process of using a survey to gather interest once you have some candidate phenomena, and how to do that. We take stock of what we learned. And the last piece is actually where we show people how to introduce a phenomenon using the anchoring phenomenon routine. And then finally, providing people with a summary Q&A. This work leads to this, Phil mentioned a supplementary resource that can go into like how to identify ones that are more local. And we're also working on one, how to begin to build a storyline from once you have a compelling anchor. So I went kind of quickly through that. I apologize, but I wanted to leave a couple of minutes. And here's where you, again, the link to download this resource. And see if there's questions for our last couple of minutes that people might have.